All right. I need to know what questions you want me to go over. I'm going to spend about 5 minutes, and I'll come back to the homework. Yes. I have not taught that yet. That's my plan for today. Yes. Yes. With it. All right. Shh. Number 4. When I'm teaching, you will be quiet. All right. Number 4. First of all, I asked you on every single problem to write our arc length formula, which arc length is equal to theta in radian measure, that's the angle in radian measure, times its radius. Number 4 said in a circle, an arc of length 5. Is that L, theta, or R? Theta. It says an arc of length 5 is an angle measured in length. It is not measured in degrees right now. It's measured in what? Radians. So it says in a circle, an arc of length 5. Is that L, theta, or R? Did it say a radius of length R, or did it say arc of length 5? It is L. The arc is length 5. All right? Is subtended by a central angle of 5/3 radians. Now, when you see the word radian, that should be a giveaway. What is that? We measure a radius in radian measurement. No, it is theta. Now, there is no pi here. Theta does not have to have a pi. That just means they've already multiplied through by pi. So that's 5/3. And if you look at the question says, what is the radius of the circle? So if you have filled something in for R, you know you've done what? You've done it wrong. Correct. That's one of the things you can. So how do we disconnect this? Because it says arc of length 5. We're going to multiply by the reciprocal. At which point you get 15/5, which reduces to what? 3. In fact, if you want to check your answers, let's go through this. Number 1 should be 30 feet. The problem with number 1 is the kids that came in before school were throwing, it said 2.5 radian. They were throwing pi's in where pi's didn't belong. Number 2 was 13.5. Again, that was 1.5 radian, not 1.5 pi radian.
So the radian is the
always the angle. Radian is always an angle.
Okay, what's the angle? The angle is which one?
Theta. All right, number 3 is 3 pi over 16. 13.5. Number 4 is 3. Number 5 I think they asked for a diameter. So you should have gotten 22 over pi on number 5 for the radius, which is approximately 7.00. So how do we get a diameter from that radius?
I don't know this right.
You double it. It takes 2 radii to equal a diameter, so that answer was 14. Number 6 was 33 over 2, or 16.5. Number 7 was 3. Number 8 was 7 radians. Number 9 was 16. Number 10 was 14. The radius was 7. Your diameter was 14. 11 is 3. 12 is 49 over 24, or 2.04. 13 is 15. 14 is 8. Now, number 8 you may have different than mine because my worksheet changed the numbers. So if you have 8 wrong, you might have done it right. 15 is 15. 16 is 12.5. 17 is 6 radians. 18 is 20 centimeters. 19 is 24 centimeters. What other problem would you like to see? 19. Okay. So 19 is the way I think the EOC will do it, because it's more of an application. It's the tip of a pendulum, describes an arc 18 centimeters long. So we have L is equal to theta times R. What is 18?
What is theta?
Theta is the angle in radian measure. It's a Greek letter. It's like an X. Okay, the tip of a pendulum describes an arc that's 18 centimeters long. What is it? L, theta, or R?
R.
Did they say the radius was, say, 18 centimeters long?
L. It's theta.
Did it say, theta do we measure theta in centimeters?
No.
No, it is L.
Oh my god.
Okay, then it says,
How do you know?
because theta is not measured in centimeters,
Okay.
and it says the tip of a pendulum, here's the pendulum, it's like on a clock, and it's a pendulum, and it swings, okay? You've got this pendulum, and it swings. Yeah, so it's describing this arc right here, which is arc length. They asked you for the length of the pendulum, and since it starts here with the swing, that is the radius.
Okay,
So now it says it swings to an angle of 3/4 of a radian. That means it's 3/4 radian. When you see the word radian, you know it's theta. We don't know R. So to solve, we're going to multiply by the reciprocal.
Wait, why don't we think of radius over here, radian? Right? Yeah, what the heck?
Radian is an angle measure. It is not a length measure.
If you see radian, it is theta.
If you see radian, it is theta.
If it's a radius, it's a radius.
That's correct. 3 goes into 18 6 times, so your radius is 24 centimeters.
What does arc mean then?
Arc
Is length?
is length, arc length. Yes, sir. Okay, number 5, and then I've got to teach. Number 5, Number 5 is talking about a slice of pizza. Okay, here's the slice of pizza. And they say that the pizza is divided into 8 equal slices, each with a central angle that is pi over 4 radians. What is that?
That's going to be theta.
That is theta.
Whoa.
So this is going to be pi over 4. She measures along the outer edge. What is that supposed to be?
Arc.
Arc length. Finds that to be 5 1/2, which in fraction form is 11 over 2. 5 times 2 is 10 plus 1 is 11. That goes in for L. And to double check to see if we did this right, it is asking for the diameter, which is part of a radius. So we're going to multiply by the reciprocal. And you're going to, 2 goes into 4 2 times, so we get 22 over pi is the radius. That's approximately 7.00. They didn't ask for the R, they asked for the diameter. How do I go from a radius? Multiply by 2. So that is going to be 28. Just kidding. I already doubled it.
Just making sure. I knew you were kidding.
So that was number 5. Well, I already did 19. That's number 5. Yes.
Leave me alone.
Because in a circle, if this is a diameter, that's a radius, and that's a radius, and it takes 2 radii to equal a diameter. All right. So now we're going to go to our sector information.
Oh my God.
All right. So we're going to come here. All right. Does anybody remember the formula for a triangle? Area of a triangle. It's going to be 1/2 base times height. Okay? They will not. No, they do not. Trevor?
Porch.
All right. This is a very small sector. I'm going to make a larger sector so you can see it. A sector would be finding the area of the piece of pizza that you are eating. That's a sector. Now, this is also a sector. Sector is just part of a circle. This is a really big sector.
Wow.
Okay? But we're going to focus on the green right now to get the basic definition of what we're doing. If I were to connect this, do you see the triangle?
Yes.
The area of the triangle is almost equal to the sector, correct? All right, so if I were to draw this segment in, this would be my base, yes? This would be my height, and I would multiply them and divide by 2.
Yeah.
So in order to take this concept and expand it to our circle, instead of a straight line, the base is a what?
It's an arc.
It's an arc. Do we know how to find that length, by the way?
No.
L equals what?
I don't know.
theta times r. Now, if I were to extend this line to the circle, what is it called that extends from the center to the circle? It's a radius. So now if we use the concept of our triangle, this is going to be the area of a sector is going to be 1/2. Our base is our arc length. Our height is our radius. Our arc length is theta times r, and our height is not h now, but r. So the area of a sector is 1/2 theta r squared.
Why are we going so fast through this lesson?
We're not going fast through this lesson. I did arc length in a whole day. I didn't do arc length and sector in a single day. Okay. Theta and r. Theta and r is our base because that is the length of the arc. All right. So this is the new formula between arc length, which is theta r, and between the area of a sector, we can do everything. Yes, Ethan?
Should like the theta and the r squared be or do you only multiply it by theta?
If I had a theta that was pi over 3 and my radius was 2, only the 2's being squared. So this would be because the arc length has an r and the radius, the height, has an r. So I would square this and then I would multiply it all together. I'm going to do an example. So here is our first example. Now, I gave you a B, C, and D. So I'm going to start here. And on the B is the only time we're going to use, this is going to be pi over 3. We'll say that this is 5. All right, so if I want to find the area of the sector, and again, the sector is this shaded region right there. I want you again to write the formula on every problem, 1/2 theta r squared, if you want full credit on your homework. What is my theta?
What is pi over 3?
Pi over 3 is my theta. What is my radius? 5. And what do I have to do to 5? Square it. So I'm going to go ahead and multiply these two first. 1 times pi is pi. 2 times 3 is 6. What is 5 squared? 25. So that's 25 over 1, so that's going to be 25 pi over 6. Now, if you want a decimal, you certainly can find the decimal. That's the area of that slice of pizza. That is part B of what you do tonight.
Oh, that's part B.
Now, listen carefully. Listen carefully. This is key information. I gave it to you yesterday. I'm going to give it to you again today. Circumference of a circle. Of a circle is the entire distance around. In other words, this is the biggest arc you can find, entire distance around.
Oh, I know that.
Okay, now, what is the angle measure that starts here and goes all the way around the circle?
Circumference.
No.
6.
In radian measures, go back to your investigation with the pipe cleaner. How many radians were in a semicircle? 3 and a little more. How many were in a whole circle? 6 and a little more. What did we discover 3 and a little more was? Pi. What did we discover 6 and a little more was? 2 pi. So here we go. When you're doing the circumference of a circle, it has to do with distance. It has to do with arc length. But the deal with the entire circle, anytime you're dealing with the entire circle, what is the angle? What is theta on an entire circle? 2 pi. So if I want the circumference of a circle, I'm working with the arc length formula you did yesterday. What is theta? 2 pi. What is the radius? 5. So what is the circumference of this circle? 10 pi. So when you do part C, We're not working with a portion of the circle anymore. We're working with the whole circle. And any time you're working with a whole circle, what will theta always be? 2 pi. So now let's extend this. And this is what I thought was so beautiful, because this is the first time with the Common Core that we've had to do radian measure at this level. So remember the area formula for our sector that we just learned that you're writing on each problem tonight. And again, on D, you will write it again. This is theta r squared. Now I want the area of the whole circle. Whenever we're dealing in a whole circle, what is theta?
6 pi.
2 pi. It's 6 and a little more, which is 2 pi radians. So what do I substitute for theta? 2 pi. And I'm still working on my same example above. What's my radius still? What's my radius? 5. And what do I have to do to my 5? Square it. So now we're going to simplify that, and that's going to be pi times 25, or 25 pi.
So each one of these are different problems that you have to work out?
They're different, yes, sort of. It's using the same circle with the same given information, except C and D is with the whole circle, which means that you're dealing with what always?
So if we don't have a whole circle, then we don't have to do it? But I'm saying, like,
Okay, so let me do another example. Let me do another example. All right, on this worksheet, they may give you the fact, and they'll do this little circle. This is what we're focusing in on. That is 3 pi over 2 radians. We're not dealing in this part. We're dealing in that part. That's a sector of the circle. We're dealing here. So if I want to do B, if I want the area, it's not the whole circle. It is what? This part of the circle, right? That part of the circle. So the area that, no, that's not 2 pi. What is it?
3 pi.
If I include what I didn't shade, it's 2 pi. So area of a sector formula is 1/2 theta r squared. What's the theta for this sector? 3 pi over 2. Oh, but give me a number.
16.
Oh, you want to square 16?
25.
Yeah.
You want to square 16? Okay, you get the calculator out then.
3.
Okay. So we've got 16. So what do I have to do to 16? Square it. So this is going to be 3 pi over 4 times 16 squared is 256. So this is, what's 256 times 3? Okay, so we've got 768 pi over 4. How many times does 4 divide 768? It goes evenly. So that's 192 pi. Okay, we're working with the theta they gave us. All right, but now I want you to do the circumference. That is basically arc length of the whole circle. Circumference is arc length of the whole circle. Arc length whole circle.
So it'd be 3 pi.
Hold on. What formula do you use?
Length,
L equals
theta.
theta times r. What's our radius on the whole circle? I mean, our theta on the whole circle? 2 pi. What's the radius? 16. So what is the circumference, the arc length of the whole circle?
32.
32 what?
32 pi.
32 pi. All right. Now, we're going to do part D. Part D is the area
But it's not, this is all.
of the whole circle. Yes. I only gave you 9 questions. It was going to be 22. If you complain, I'll give you the other 20.
So B is just looking for.
What, that part. Then everything else is the whole circle.
C is like the around, and then D is like the entire thing.
Right. Right. Don't pack up. We've got 3 minutes. I'm not done.
3 more minutes.
All right. So now we're doing area of whole circle. What is my angle? On the whole circle, what's my angle? So this is going to be 1/2 times 2 pi. What's my radius?
16.
16 squared. So that's going to simplify, and we're going to get 256 pi, and that's the area for my
Wait,
whole
serious about this?
circle.
Like,
Yes,
problem. Like, literally one problem.
we need to talk,
Oh, no, I didn't.
and we're going to talk. Oh, you're working on that.
Because I'm with notes. I'm doing notes when I get home. I don't understand all this. I was doing it yesterday.
In math class, you will focus on math and no other subject. Okay? All right. Any questions on the assignment? It is not I cut the problems down. It's not an unfair amount of work.
Unfair amount of work. This is
All right. You know what? You can do whatever you want to do. However, if you want full credit on this assignment, I expect B, C, D on the problems. Yes, I need your homework passed to the center.
Alright, they are going to come after school and then go over the homework.
Oh, you got it.